Welcome back to my friend's workshop. Why waste gas is the question we asked in our previous videos when we introduced our new Integra E2 cylinder. The videos discussed leak detection, flow control and surge protection, all with the objective to ensure you to stop wasting gas. In this video we will explain you the flow consistency functionality. What do we understand by flow consistency? If we look at the standard cylinder setup, the flow rates are controlled by a standard regulator connected to the outlet valve of the cylinder. This standard regulator, as already explained in the flow control video, can easily be set to give an excessive flow rate and therefore lead to considerable excessive gas waste. Often this type of equipment is poorly maintained, or when buying poorly manufactured and inexpensive regulators, the flow characteristics of this regulator can be very unstable. How can this happen? When we set the required flow on the regulator connected to a full cylinder, by turning the black dial, we are in fact regulating the spring and setting a force inside the regulator against the cylinder pressure coming into the regulator's body for the regulator to open the valve just a little bit and still allow the required flow of, for example, 15 liters per minute to pass. The initial set force by the spring in the regulator to open the valve slightly and allow the desired flow to pass is not altered along the lifetime of the cylinder. And because the 200 bar pressure slowly decreases while the cylinder empties, the regulator with its basic mechanics inside will slowly but surely open more and allow more and more flow to pass. And so the flow rate will slowly but surely increase gradually when the cylinder pressure goes down. If we do not alter the flow settings on the regulator while the cylinder pressure goes down, the increase of the flow rate can easily range from 30% or more. So talking in real numbers, a flow set on a full cylinder had 200 bar to be, for example, 15 liters per minute, can easily be 18 liters per minute or more as the cylinder empties. The flow has gradually increased along the lifetime of the cylinder. We call this the instability and flow inconsistency of the regulator. This makes you waste a substantial amount of extra gas or reduce the lifetime of your cylinder connected to a standard regulator. As I already mentioned, our engineers have thoroughly redesigned the Integra E2 regulator and used highly advanced components as well as applying a different regulator build-up to make it possible to avoid the instability of the Integra E2 regulator and create a better flow consistency. This means that when you use the Integra E2 cylinder and select, for example, the E15 IFO, the flow at the torch with a full cylinder and an almost empty cylinder will be equal or with a maximum variance of plus minus 1 liter per minute. Let's check this by means of the setup here. This Integra E2 cylinder on the right is a full cylinder. You can check that on the display and see indeed that it is full. While this one is almost empty, also visible on the display of the cylinder. Equally, the cylinders in the back, this 200 bar cylinder is at 200 bar and almost full, and the one on the right here is almost empty or has a remaining pressure of 30 bar on the gauge. I have already connected the standard cylinder regulator to the full cylinder, connected the gas hose. The only thing that's left now is to check the flow that I have exactly at the torch, which I will measure with the digital gas flow meter. I open the valve slowly, away from the cylinder. The welding gun is connected to the flow meter. I pull the trigger of the torch. So, exactly 15 liters per minute with a full cylinder at 200 bar pressure. I will now unmount the regulator gently from the 200 bar cylinder without touching the dial and connect the regulator to the cylinder on the right, which is almost empty or at only 30 bar remaining. I close the cylinder valve, release the pressure, don't touch the dial. Tighten the spanner. Connect the gas hose. Also tighten with the spanner. Open slowly the valve. Like I said, I did not touch the dial of the regulator. The welding gun is connected to the flow meter. When I check the flow now at the torch, measured with the digital flow meter, I measure 19 liters per minute, or the flow has increased with more than 25%. The cylinder content is between 30 and 40 bar. Let's do the same test now with our Integra E2 cylinder. I will select the E15 IFO and connect it to the hose of my welding machine. I connect the IFO to the outlet of the cylinder. I tighten to make sure I have no leaks. I put the power arm in the echo position. Again, I pull the trigger of the welding gun and the flow meter reads 15 liters per minute with the contents indicator on the Integra E2 cylinder display showing the almost full cylinder. I close the cylinder again. From the Integra E2, I disconnect the IFO and will now connect it to my almost empty Integra E2 cylinder. Put the power arm in the echo position. I pull the trigger of the welding gun and the digital flow meter reads 15 liters per minute with the contents indicator on the Integra E2 cylinder display showing the almost empty cylinder. Conclusion. The Integra E2 cylinder again performs as designed and delivers the promised gas savings. All the functionalities we have demonstrated in previous webcasts have delivered savings from 15% up to 50% at the first customers to take these products. Obviously, the savings depend on your application, setup, maintenance, etc. But your local Air Products application specialist can work with you to optimize all settings to ensure you get the maximum benefit. Clearly, the new Integra E2 cylinder is a sustainable way of using gas whilst saving you money and helping improve your carbon footprint. We look forward to speaking to you soon. Thank you and goodbye.